Okay, this is our lesson on, this is what I'd call 2.1a on linear and quadratic functions and modeling. Some of this we're going to fly through and even skip over because we've done it already. The definition of a polynomial is basically a polynomial can't have any negative or fractional exponents. If it does not have a negative or fraction exponent, you're good to go. It's a polynomial. The degree is the highest exponent, and the leading coefficient is just the number in front, and that's if it's a polynomial. So here we just look at our exponents. That one's not negative or a fraction. That's not negative or a fraction. So this is yes, it's a polynomial, and the degree would be 3. If it asked for the leading coefficient would be 4. On part B, that negative 4, that is a negative. So it's not a polynomial. If it's not a polynomial, then you can't say anything else. This one could be rewritten as 9x to the 4th plus 16x squared to the 1/2. That's a fraction, so it's no. This one, that 1 is fine, that 4 is fine. So it's yes, it is a polynomial, and the degree would be 4. If it asked for the leading coefficient would be negative 2. We've done this again. 0, the 0 function is just y equals 0. A constant function is y equals a number. Linear, like y equals 3x plus 1. A quadratic is anything if its greatest degree is squared. And those were our parent graphs. So, example 2. Write an equation for the linear function f such that f of negative 1 equals 2 and f of 3 equals negative 2. An equation of the linear function, aka the equation of a line. Y equals m times x minus x1 plus y1, that. So, it's written weird though, but we know that f of x equals y, so really they just gave us 2 points. They gave us the point negative 1, 2, and 3, negative 2. So we would just say that's x1, y1, x2, y2. So m equals y2 minus y1 over x2 minus x1. So negative 2 minus 2 over 3 minus negative 1. So that's negative 4 over 4, which is negative 1. So negative 1, and then you just pick a point. I like this one better. So 3, negative 2, and I'm done. Just erase this picture. Forgot to go in and erase that. Another property that characterizes a linear function is the rate of change. The rate of change, the average rate of change, is defined as f of b minus f of a over b minus a. That's just another way of saying the slope. Because if you had a f of a, that's just x1, y1, and b f of b, that's x2, y2, it's just y2 minus y1 over x2 minus x1. So when you see the word average rate of change, it's just asking you to find the slope. Again, stuff we've done before. You should have done this algebra 2. Strong positive means you can draw a line through it. Weak positive means it's rising, but it's not. You couldn't draw a line through that. You could, but it wouldn't be very accurate. No correlation, and then a strong negative and a weak negative. And moving on. Use the data in table 2.2. We did not do this in class today because it's asking us to find a scat. We've done this, and we would just do it on our calculator. And we would go put our data in here, and then we would go back and do this and make our scatter plots. And define the regression equation. We've done this before. They elected not to they decided to skip it today, so I'm going to skip it now. I did not do a good job of erasing my stuff. Wow. I'm sorry. I thought I did. Clearly I did not. Okay. Where am I? Right here. This is describe how to transform the graph into the graph of the given function. Sketch the graph by hand. Well, it would move up 3. and it's reflected vertically over the x-axis, and it's the 1/2, random pen mark, the 1/2 shrinks it vertically, so it's just going to make it wider, and it doesn't have to be perfect. We're just sketching. This one moves left 2, down 1, and it's skinnier. It's stretched vertically by 3. Describe how the transform. I don't feel like writing those out. The first one, up 3, shrink vertically, reflected over x-axis. Stretch vertically, left 2, down 1. This is new. Converting vertex form, standard form into vertex form. This is standard form. This is vertex form. And you rewrite it first, put it in standard form, so it would be negative 3x squared plus 6x minus 5, and we do what's called a modified completing the square. We group the negative 3x squared plus 6x together and add a blank, and then the minus 5, and you minus a blank. Whereas on completing the square, you add a blank to each side. On this, we're doing it on the same side, so you have to add a blank and subtract a blank. But remember, with completing the square, the number in front of the x squared has to be a 1, so I have to factor that out. Negative 3x squared, this would be a minus 2x, and I'm going to factor it out of my blank as well, because that's where I'm completing the square. And then it's what goes in the blank. Half of negative 2 is negative 1, squared would be a positive 1. And in my blank, I can't change my equation, so whatever I added onto my equation here, I have to subtract. So negative 3 times 1 is a negative 3. So it would be negative 3. I factor this into x minus 1 squared, and then plus negative 5 plus 3 is negative 2. So my vertex, it's ax minus h squared plus k, is 1, negative 2, and my axis of symmetry is just x equals this first number in my point, x equals 1. Let's do that again. Maybe. Where's my question? There it is. Use completing the square to describe the graph. Support your answer graphically. We're going to do the same thing. We're going to factor out the 3. X squared plus 4x plus a blank. Whoops, that's a 1, not a blank. Plus 11 minus a blank. Half of 4 is 2, squared is 4. So it's going to be x plus 2 squared. Oops, what goes in my blank? 3 times 4 is 12 here, like if you distribute it out. So that would be minus 1. So it's going to move left 2, down 1, and stretched vertically. And my vertex is negative 2, negative 1. My axis of symmetry is x equals negative 2. And then here's this random, I thought I erased all this, but I didn't. Random example that you have to write down. It's not in your notes. Write an equation for the quadratic function whose graph contains the given vertex and point. We're going to use the same equation. And in order to write the equation of a parabola, basically you need blank, x minus blank squared plus blank. You need a, you need h, and you need k. Well, this one gave us h and k, because my vertex is h and k, and my point is x and y. So I fill it in. Y is 8 equals a. I don't know. That's my variable. X is negative 6 minus negative 4 squared plus k is negative 4. So 8 equals a times negative 2 squared is 4 minus 4, and then you just solve it. Add 4. 12 equals 4a divided by 4. A is 3. So my equation, a is 3, h is negative 4, k is negative 4. So my equation would be y equals 3, x plus 4 squared minus 4. And I'm done. Yep, and your homework are those problems on page 169 in your book. And I posted that for you on Edmodo.